Hi, I'm Metta Spencer, and today we get to go to Mississippi. And it's this place called Starkville, Mississippi, which I am afraid I've never been to, but we get to meet a very special person. Heather Alexander is a professor of forestry at that university. She says she's really not a forester, but an ecologist, but I'm going to call her a forester because we're going to talk about trees. And she certainly knows a thing or two about trees. She goes every year to Siberia and hangs out with people who are worried about permafrost up there. And my concern these days, in fact, I'm losing sleep over it, is the rapid thawing of the permafrost in the world, which covers a large part of the world's land, soil. The rapid melting of this ice in the soil, which is allowing bacteria to come back to life that have been frozen for 30,000 years or more. And they are hungry, and they are eating frozen grass or other vegetation, even maybe animal remains that have been frozen in the soil. Mm-hmm. This then generates methane, which is getting into the atmosphere. And since methane is 30 times or so more powerful as a greenhouse gas than carbon dioxide, my numbers are wrong. Heather will correct me about the ratio, but at any rate, it's a bad situation because if methane gets into the atmosphere in large amount, it will warm the climate, and that will melt more permafrost, and it becomes a runaway situation, and we are facing an extinction event, potentially. If I sound like an alarmist, it's because I am, and maybe unfairly so, but I want to have a conversation with somebody who really knows this stuff, who's actually working on the situation of the trees and the permafrost and the vegetation in the Arctic and so on. So hello, Heather Alexander.
Hello, Metta. Thank you for having me.
Yeah, it's a real pleasure. Because I think there's a lot yet to be discovered about these problems, right? And you're in the middle of it. Okay.
Yeah, so I have been going to Siberia since 2010. Every year I lead a team of scientists from across the US, and we collaborate with Russian scientists, and we bring students, and we go to Siberia to better understand how that system is responding to climate change. We're specifically interested in understanding how climate is affecting giant, massive wildfires that are happening in that region, and the connection of those fires to the permafrost soils that lie beneath them, as well as the recovery of forests that are burning. And we go to Siberia specifically rather than addressing these questions in the US because Siberia contains what's known as Yedema permafrost. So permafrost are soils that have been frozen for at least 2 years continually. But many of these soils have been frozen for millennia, thousands and thousands of years since the end of the last glaciation event about 10 or 11,000 years ago. And what's interesting about Yedema permafrost soils is that they contain, by volume, about 30 to 50% ice. And then they're also rich in carbon, like you described, this undecomposed carbon of plants and animals that has also been frozen and locked up for millennia. And so as you can imagine, that if this ground, I say ground because it's not all just dirt, we think of soils as dirt, but really it's dirt embedded in a matrix of ice. If that ice melts, as you can imagine, it's not just like the ground gets warm, but it subsides or collapses. And so then you have the potential to expose very, very, very deep layers in the soil that have been frozen for thousands of years to the atmosphere. And when those soils become exposed to the atmosphere, the bacteria, either bacteria that was frozen and becomes alive again, or new bacteria, start to break down that carbon. And they want that carbon for their own energy so they can grow their own cells. And as they break down that carbon to acquire the energy, they don't use all of it. Some of it gets released into the atmosphere as CO2 And then in very moist environments is methane. And like you said, methane is about 30 times more potent of a greenhouse gas than CO2. Mm-hmm. And so we're really interested in what happens to these permafrost soils after fire, because fire in and of itself is a major pulse of greenhouse gases into the atmosphere. But
okay, if you don't mind, before we get to fire, I want to explore this Yedema business, because you say you go to Siberia because that's where the Yedema is. Mm-hmm. I wonder, I saw a graph not long ago showing that the amount of carbon locked in the soils in Siberia was stupendous.
That's right.
More than any place else in the world. I mean, like multiple times as much. And I don't know why. And if, let's say, Canada and Alaska are both in the Arctic, is it true that we don't have the same kind of carbon-laden permafrost that Siberia has?
So there is Yedema in Canada and Alaska, but it's not as extensive as it is in Siberia. So Siberia is a huge region, right? I mean, the boreal forest itself, which occurs largely in the Arctic and the subarctic, I mean, is 13 million square kilometers. So it's larger than the continental US. And most of that is in Siberia. And so, yes, there is Yedema in Alaska and Canada, but not as much. Well, it contains more carbon because it's such a bigger area, right? So much of it is there. So interestingly enough, just to back up a little bit, the atmosphere right now stores approximately 750 gigatons of carbon. The permafrost, which lies in the Arctic and the subarctic regions, which include boreal forest or taiga, so this stores approximately 1,500 gigatons of carbon, which is about twice what's in the atmosphere right now. Mm-hmm. And so people are very worried about the collapse and the potential release of this carbon into the atmosphere, because it could essentially cause, people call it a carbon bomb, a massive pulse of CO2 and methane into the atmosphere if the permafrost were to melt. Alaska is very tiny in area compared to what Siberia is. I don't fully understand why Siberia has so much more Yedema. It cooled and formed very rapidly, which is one reason why it has this ice. And the ice actually accumulated over time. Like it would get a little crack in it, the water would come in and it would freeze, it would crack more, water would come in and it would freeze. And then the organic material that it's rich in was frozen very quickly.
I believe a couple of years ago, or maybe just last year, your friend and colleague, Susan Natali, was the lead author for a big paper that shook everybody up, if I'm not mistaken, by concluding that there's more carbon being emitted from the Arctic now than is being sucked in and sequestered. So it's not a sink, but a source of carbon now.
I think the fear is that it will become a source. I don't know that we have the accounting completely figured out yet. Certainly, if the permafrost melts, it will become a source. And there are a variety of other mechanisms that would allow it to become a source too, which I mentioned fire before. That's inevitably you can't decouple that from permafrost in those systems. Mm-hmm. And so there is great fear that those systems, which have been sinks for millennia, will now become sources.
Mm-hmm. Well, let's talk about all the variables that would determine whether or not it is a net source or a net sink.
I mean, there's a couple of things. One, fire is really important because fire is basically like decomposition sped up very quickly. It's a way that which organic material is broken down and then can be released into the atmosphere. So if you think about it, fire moves through, and as fire is burning organic material in trees or in soils, and that gets emitted into the atmosphere along with smoke and other things as well, right? But it could be a massive pulse of greenhouse gases into the atmosphere. So if fires start happening more frequently, more severely, burning more extent, then they're burning carbon, basically, putting it into the atmosphere.
The firestorms are increasing.
That's right. It's pretty massive. In the last several years, I'm sure people, I mean, we hear the news all the time about the fires in the Western US, but in Australia and the Amazon. Last year in Siberia, there were massive, they call them mega fires. These fires were so large, you could see the smoke from outer space, and that smoke was drifting towards the United States. And people that those systems are supposed to burn. Fire has been part of their ecology for thousands and thousands of years. And so these are usually fires that were ignited by lightning, and they burned every, 80 to 250 or 300 years, depending on where you are situated. Now these fires are happening much more frequently. They're burning systems that never burned before, because those systems are now drier because the climate is warmer. And then we have a fire season that usually extended only a month or two during the brief growing season in the Arctic is now extending 3 or 4 months because it's much warmer. And now we have more thunderstorms, more lightning ignitions. And these are vast remote areas that have no, in the US, when a fire happens unintentionally, we go out and we fight it. But these are places we cannot fight, even if we wanted to. Plants photosynthesize, right? So as long as they regrow and they suck up that CO2 that was emitted during the fire back and put it back into their tissues, then it might not be a problem. And that's what normally would have happened. But with climate change and climate warming and drying.
So now, if it were a normal, old-fashioned forest fire, the net effect would not be an addition to the carbon in the atmosphere, because quickly the fast-growing small trees would suck up whatever they had been emitted by the fire. Is that right?
Yes, most likely. Although in nature there are always extreme events, but not the norm, right? So you have to think of the time scale too, right? So it's not just like, there's a pulse of CO2 or methane with the fire, and it takes the trees or the shrubs or whatever else many, many years to recover. So we call that the successional intervals, what ecologists call it. It's the interval over which those vegetation grow before they're disturbed again. So normally they have 50, 100, maybe 200 years to reaccumulate that carbon that was lost during the fire. And as long as they do that, then there's no net pulse of greenhouse gases into the atmosphere. What we're seeing now is that they either don't have the time to recover it because the disturbance happens so frequently. It happens, now we're seeing fires reburning areas much more commonly than we ever have seen it, at least in the last, what we can detect from sediment cores and things like that over the last several thousand years. So they're burning more frequently. They're burning much bigger areas. And they're burning way deep. These Arctic and subarctic systems are so interesting because it's cold. Some places are very wet, some places are dry, but both high moisture and very dry conditions limit the decomposition of any organic material that's formed. And it's getting into these organic layers, but that's what's fueling a lot of these fires, is the organic layer. And now the fires are burning much deeper into the organic layer.
Now, the organic layer, I've heard that there's a lot of peat.
Yes. Oh, so this is the other thing.
I don't understand how it burns without oxygen.
Well, what happens is peat is comprised largely of mosses, like sphagnum mosses. And mosses have a very low bulk density, which means that they're not very tightly packed. They're very loosely packed, kind of like, the fluffy material in your pillow. Mm-hmm. And so there's lots of little air spaces in it. And so those air spaces become filled with water when the conditions are moist, but when it dries, which is happening in a lot of peatlands, those spaces are no longer filled with water and they're filled with air. And then all you need is an ignition source, and you can have a fire even burning in a peat bog. And you could imagine that carbon has been accumulating for many, many years. And so now you've got this, they call it old carbon. Mm-hmm. So, if you're burning new carbon, only carbon that's been accumulated during that successional interval I just described, it's not a problem. But you start burning deep into things that has been locked up for thousands of years, then you've got a big problem. And that's what's happening in a lot of these systems.
Well, I remember about 4 or 5 years ago, I have a lot of friends in Russia, even near Moscow, the smoke was really bad from peat fires, as I remember. How do they fight a peat fire?
Oh, that's a good question. I'm not really sure. I mean, I would assume that they fight it like they fight other fires with, massive hose, and they use water, of course, but then they also kind of go in and rake out fire lines so that the fire can't continue to spread. So they basically just remove the fuel around the edges. There's obviously concern for human health. I mean, I've been in Siberia in summer times doing research. The year before last, we were in Yakutsk, which is in central Siberia. And it was almost impossible to work because the smoke from the fires was so bad. And so it's very clear when you go there that things are changing for sure.
Yeah.
People talk about it a lot in terms of their livelihood, and the way that they do things is being completely.
I read an article a few months ago saying that although trees theoretically sequester a lot more carbon in general, because they're bigger, they have roots, etc. They suck carbon out of the atmosphere and put it underground. That because of they can burn so badly. Instead of having forests, you'd be better off having grassland in the same area. Is that a reasonable claim?
I think it's a little tricky because, one, when a grassland burns, it's not necessarily the same magnitude of a forest fire, but grasslands burn more often. In fact, in order for a grassland to remain a grassland, it has to have, in most grasslands, you have to have pretty frequent fires, because the fires are what are keeping the woody species from growing, keeping the trees from growing. So grasslands are usually maintained by a combination of frequent fire and herbivory, so animals that are coming in and grazing on that grass and keeping the woody species from coming in. And so you may not have a single fire of the same magnitude that you would have in a forest, but you would have much more frequent, lower intensity fires that over a period of time would probably equate to the same level of a single forest fire, if that makes any sense. So you can't maintain a grassland in most cases unless you have fire. And fire, and when I say frequent, I mean every 3 or 5 years, a fire would have to come through. So while a forest may only burn once, and depending on the forest, boreal forest, say every 100 or 150 years, a grassland would have to burn every 3 years. And so over time, it probably equates to the same thing.
Okay, what happens to wildlife? I mean, we see pictures of poor kangaroos in Australia now, and they said 1 billion animals have been killed by the recent forest bushfires.
Sure.
Does this really have a terrible effect on the population of animals?
That's a good question. And I think I work a lot with wildlife ecologists, and what I have learned over the years is that it depends on the fire. And so I want to clarify. I think a lot of people are confused about fire because we've sent a lot of mixed signals about fire in this country, particularly. We have a message of fire being detrimental and harmful and causing a lot of problems in terms of human life and property and that of wildlife. And then we have this other message of that, sometimes fire is good. Like, we actually intentionally set fire sometimes in this country for certain ecological management objectives, as well as to protect people and property. And so what we have to understand is that fire is a ubiquitous occurrence across any terrestrial ecosystem, land-based ecosystem. So fire can occur in all but the wettest of ecosystems. And in most places, it's not a matter of if it burns, it's a matter of when was the last time it burned. And so I'm saying this because most terrestrial systems will burn, and the organisms that have evolved in those systems have evolved in the presence of fire. Now, that fire could have a very different fire regime, meaning that, like in grasslands, fires occur very often, but they're not very severe. In forests, they occur less often. And depending on the forest, like in the oak forest that I work in the eastern US, the historical fire regimes were somewhere between 7 and 15 years, while in the Pacific Northwest, they may be every 300 years. So the point I'm trying to make is that as long as the system is functioning within a range of variation that it's used to or has evolved with, then the animals know how to deal with that fire. they have mechanisms. Like if you think about the longleaf pine systems in the southeastern portion of this country, there are gopher tortoises. Gopher tortoises burrow. They create burrows that they go into during fire. And not only do they go into them, but many of the other animals that have evolved into that system use those burrows. And so they can go beneath ground when fire happens. There's been other studies in oak forests that have shown that little box turtles that hang out in those forests, they actually, when a fire is happening close by, they sense it and they move. They move out of the area. They understand fire. Wild turkeys in the eastern US, they actually come back in and roost right after fire. They know that fire is going to expose the insects that they need to eat. And so my understanding is that as long as the system is behaving within its normal range of variation and is not being messed with, usually by us as humans, that the animals know what to do. It's when you have something like climate change, which is causing many environments to become warmer and drier than they have previously experienced in the last several thousand years at least, or maybe never, depending on who you talk to. The conditions are not within the normal range of variation. And so then things are so extreme that sometimes the animals can't deal with that. And so that's what I think we're seeing in Australia. And that's what we're seeing with some of the mega fires that we have out west in the US, is that we have manipulated the system either through climate change or in this country through intentional fire exclusion for decades, that we've knocked the system out of whack.
We've also got bugs. 2 years ago, I drove across Canada. Forests of conifer forests were red color. As far as the eye could see. It was amazing to see these hills covered with red trees. They had been killed by
a pine bark beetle, maybe.
Yeah, those dead trees are going to fall over and rot, and the carbon will go back into the atmosphere that way. And at the time, I was reading a lot about biochar. And I thought, biochar is wonderful. It will sequester carbon for 1,000 years. I mean, it doesn't go back into the atmosphere. And I thought, why don't they go through there, take these trees and make them into biochar, and then give them to farmers or sell it or mix it in with fertilizer or something, so that we get value from it. And these trees then they will have killed the pine beetle. That's what they're called. So I came back full of enthusiasm for the idea of getting the Canadian government to make these mountains full of trees into biochar. You can imagine what an economist would say to me. Where's your market for this stuff? So it didn't get anywhere. But as an ecologist, does it make sense? If we could afford to do it, would that be a partial solution?
Well, I mean, charred soil or charred wood particularly can remain in the system, like you said, for a very, very long time. And there are a lot of studies sort of when we quantify the effects of fire on these systems, we often take into account that amount that goes into char, because that is a long-term place where carbon can be sequestered. And so you're absolutely right there. Whether or not you could do it at the scale that it would make a difference, I don't know. I'm not aware. I mean, theoretically it makes sense, but I don't know about logistically.
I had this fantasy of how you could do it, that you could of course there are no roads going into these areas and you wouldn't be able to get people in there very well, but you could, they make these ski lift things with ropes, and they're movable. You could put these pylons up and put ski ropes, and you could send people and trees and things in there, cut down your trees, and right there you could put a pit, and you could put your wood, felled wood, into the pit, cover it up, set it fire, make your biochar right there. And I think that would keep the smoke and the carbon from getting, or most of it from getting into the atmosphere. But I never heard anybody talk about how much that would actually cause. And
Yeah, I don't know. I mean, you definitely, in the process of changing wood into char, you're going to lose some of that wood, right? Like you can't just get it all to be char. You'd get some proportion of it as char, and other parts of it, like you said, would become
Mhm.
CO2 or methane. And whether or not you could uh, develop a pit system to where you could pump that into in below the ground so that it wouldn't end up in the atmosphere immediately, I don't know. That's an idea.
Mhm.
And so you would have to go through some sort of accounting procedure
Mhm.
to figure it out.
Mhm. Well, I don't think anybody's going to do the accounting because the economists would tell you it's going to cost too much to do that. But how do you think in terms of yourself? What are you going to do? How are you going to prevent forest fires? I mean, clearly the explanation you've given is that global warming is causing it to increase,
Sure.
and it's going to be a while before we can master the global warming enough to reduce the number of forest fires. What in the world are we going to do?
Yeah.
Because in the short term, these fires could, exacerbate things so much that, it could be game over. I mean, am I exaggerating?
No, I mean, I hope it doesn't happen in my lifetime, but I worry about the fate of this planet because it's such a miraculous thing that we have here. And it truly is a miracle if you think about this planet and just life in general. But I mean, I certainly think that there are things that we can do to mitigate the potential for extreme fires in this country and probably in portions of Canada and Alaska as well, where we can get to and we can prevent massive wildfires from happening by intentionally burning. So there is a lot of prescribed fire efforts that are going on where we go into forest or grasslands or whatever ecosystem, and we intentionally set them on fire under very controlled conditions. So we remove or lessen the possibility that if they were to burn unintentionally, that they would burn out of control. And so I do think there's merit to that.
Native people always used to do
Oh yeah,
burning as part of their regular farming and so on.
yep.
But I don't know how they did it. What are the principles that you use if you were prescribing a burn? How would you say, how would you run this thing?
You actually write a burn plan that details the characteristics of the parcel of land that you would like to burn, and then the conditions under which you will set the fire. And so there's all sorts of weather conditions that come into play that govern how the fire will burn and how the smoke will spread, because that's a big issue, and especially near urban areas, right? So you want to make sure there's good lift, and that when you set the fire, that the smoke is going to rise and go into the upper atmosphere. You don't want it settling on a road or a city. And so a lot of weather conditions are taken into account. You only burn on certain days where you think you're going to have the right conditions, right relative humidity, the right wind speeds. You also go into that site and you assess what potential hazards there are in terms of things that could cause big sparks, like standing dead trees that might start shooting flames out of them and cause sparks to fly outside the area that you want to burn into an area that you don't want to burn. You will sometimes rake around those so that the fire won't carry up to them and cause a problem. So you would do work to prepare the site prior to the burn to make sure that it didn't get out of control. You put fire lines or fire breaks around it.
Okay, so you chop down all of the vegetation in strips that set the boundaries of where you want your fire to
yes. Yeah, or like we in eastern forest, because most of the fuel is leaf litter and small pieces of wood, we just take leaf blowers out and we'll blow a line around wherever we want to burn. So as long as there's nothing organic along those edges, meaning grasses or dead wood or leaves, the fire won't spread unless a spark jumps the line, right? And so those standing dead trees and things like that are really important because you don't want a spark to jump that break or that line that you just put in. Mm-hmm. And so there's a tremendous amount of effort that goes into preparing for these prescribed fires. Mm-hmm. You want to and then you have a bunch of people, right? You have a bunch of people, you have water, you have, they call them flaps to like flap out the fire or stomp it out. You have rakes and you have chainsaws if you've got to cut pieces of dead wood out. And so you have a crew, you have everybody's on radios, and you have a boss called a burn boss who's basically leading this whole thing. And then you burn under very controlled conditions. And what that does is it prevents the accumulation of fuels over time. And that's part of the problem we have out west, is that because we intentionally suppress fire for 80, 90 years, fuels have accumulated. So this is just dead wood on trees that are dying, or shrubs or whatever else. And it's very dry, so things don't decompose very quickly. So now you've got all this fuel. So if someone throws a cigarette out the window, it can cause this massive giant fire. And we mismanaged our forest out west for many years as well too. So that's part of the problem. We removed fire from the system. We allowed those forests to become very dense. Like if you look at old photographs of forest out west, they used to be much more open, kind of woodlands, trees, but then grasses, and now they're very, very dense. So then we have problems with fire spreading very quickly because the trees are so densely stocked, and then issues with things like the pine bark beetle that you mentioned. Those pests and pathogens can spread much more rapidly because the trees are so close together.
Now, when you have a prescribed burn, how big an area do they do at a time?
It depends.
A city block, or are we talking about many square miles?
It depends on the system. I mean, it could be quite variable. I mean, I've been on prescribed fires that have burned a couple of acres, and I've been on ones that are burning thousands of acres. But the prescribed burning, people, it is a potential way to stop giant mega fires happening in some places, but not on all places. Like the Arctic is some place that we cannot do that. It's not feasible.
Why?
The fires are going to burn, and I don't know that there's anything that we can do to stop them other than trying to get emissions under control. I don't know what that would be, because we can't fight them.
Just because you can't carry that much water in planes to that far, is that it? Or what? Why?
Can't get to those areas. They don't have roads, or they don't have places for planes or helicopters to land.
Okay. How about just trying to keep the forests from growing there? Because my understanding is that the tendency now is that as the earth warms, and maybe for other reasons as well, such as lack of animal life that could stomp on the soil and whatever, that for various reasons, trees are growing farther and farther into the Arctic, and that in itself poses a risk. What is a commonly accepted point of view among foresters about how positive or negative this situation is? I think it's agreed that they are growing into the Arctic and that they will continue expanding into the Arctic. I don't know how fast, but is it generally considered a hazard, or overall a good thing, because the trees will be sequestering carbon if they don't burn? And it may vary according to the species of the trees. So can you elaborate on the desirability of trees in the Arctic?
Well, it's, again, a trade-off. And so I go back to that a lot, right? So, I mean, trees do sequester more carbon than grasses and shrubs that are growing in the tundra right now. But the only way that trees are going to be able to move north into tundra, from the boreal forest into tundra, is if the permafrost thaws some. Because right now the trees are restricted from being in the tundra because the soils are so frozen, and they are not thawed sufficiently enough to support the roots of trees and the amount of water and nutrients that the trees need to grow. So if you have a very, very shallow amount of soil that is unfrozen during the growing season, which is the case right now in the tundra, only shrubs and grasses can grow there, because trees wouldn't have enough volume of unfrozen soil to be able to grow in. Does that make sense? So
Yeah, sure. And so far, go on with the other balance. Now you've got.
Yeah. So, right. So, and so the point I'm trying to make is that you might have trees moving up into this region and potentially sequestering more carbon in their above ground tissues, but inevitably there will be a loss of some carbon from below ground because you've just deepened the permafrost in order for those trees to get there. Albedo is basically a term that describes the reflectivity of a material or how much energy they emit. And so things like grasses have a very high albedo. Snow has exceptionally high albedo. It reflects a lot of energy back into the atmosphere. And so trees, if systems shift from grasslands and shrublands to forest, that could potentially cause a big reduction in albedo. So more absorption of energy by the forest than there will be from grasslands and shrublands, which could not only warm the soils more, but cause warming. And so you have to consider both the carbon sequestration potential as well as this energy change that would happen. Now, some trees like evergreen conifers, like spruces, black spruce and white spruce that hold their needles year round, would have a much more impact on albedo than a deciduous tree like birch or aspen.
Oh, now say it again. More impact how? Is it birch trees are warm the soil more than conifers, or
Well, they would.
Spruce?
So spruce trees would absorb more heat by their above ground tissues, right? Because they're darker all year round. Mm-hmm. So they're kind of like little black spots on the snow. Mm-hmm. So they would absorb heat. A deciduous tree like a birch or an aspen, or even larch, which is a conifer, but it's deciduous and occurs across Siberia, they drop their leaves every year. And so their effect on albedo is not as strong. But the deciduous trees reflect more energy. And so they actually can have a cooling effect on climate. But the trade-off, there's a trade-off there too. So, okay, spruces might have a warming effect on climate through their tissue, while deciduous birches and aspens might have a cooling effect through their leaves, reflecting a bunch of energy back. But there's a soil dynamic that isn't accounted for in that.
Okay, I'm really puzzled now because I've heard the opposite. Not the explanation isn't the opposite, and I'm not within my. I don't think I have any right to refer to somebody's research that I don't know enough about, but I will anyway. So I may be wrong here. I talked to a guy named Ian Hartley in Britain, who's at Exeter University and does work in the Arctic. And he said that birch trees have a warming effect on the soil. I think his initial paper said that underground, there's more decomposition of the soil. I don't know what's wrong with their roots, but they do more to decompose organic matter in the soil. Whereas black spruce have a cooling effect, or overall maybe have a cooling effect on the soil. And I don't know whether it's because of albedo or something about their roots.
Right.
So it sounds like you don't agree.
Well, there's two different things going on here. And that's, I think, why it's a little bit confusing. Because there's the impact of the above ground tissues of the tree, which is what I was describing with albedo. Mm-hmm. I think unquestionably, a darker tree will have a lower albedo, so something that has dark needles versus something that has light foliage, like a birch, are very different. Something that's dark is going to absorb more heat, and something that's light is going to reflect more heat. And so actually, that difference exists between spruce and birch, but that's different than I think what you're describing. The difference. So what I just described is kind of an above ground or a leaf effect. But then there's this below ground effect. What spruce do that's different than a birch or an aspen is that they tend to accumulate a lot of organic material in the soils. They tend to grow on colder sites that are nutrient poor. Decomposition rates are very low. So they tend to accumulate a very thick organic layer. Deciduous species, on the other hand, grow on drier, warmer sites. They have leaf litter that breaks down very quickly. They don't accumulate a thick organic layer. That's important because a thick organic layer, which the spruce will accumulate, is an insulation. It provides insulation for permafrost that's beneath it. It prevents that permafrost from warming because it's insulating it. And because that organic material is accumulating, and it's accumulating slowly, but it's building up, that's a carbon pool. And so those systems, the spruce systems, tend to store a lot of carbon in the organic layer. That organic layer protects the underlying permafrost.
Do they have their roots closer to the surface or something?
Absolutely, yes.
Okay.
The deciduous trees, the roots, they go down very much deeper, the birch and aspen.
Do they get do they somehow penetrate the permafrost itself?
Oftentimes those trees, it depends on sometimes those trees grow on sites where there's not permafrost. Sometimes they'll grow on permafrost sites, but the permafrost is much deeper in the soil profile. Mm-hmm. So like spruce tend to grow on sites where the permafrost is close to the top, right? So very shallow rooting zone. Mm-hmm. The deciduous trees need more rooting volume. They tend to have a pretty long, deep taproot. They have to go deeper into the soils. So they need at least the top part of the soil to be unfrozen. But they do not accumulate. That leaf litter, it breaks down very quickly. They don't accumulate a very thick organic layer. They don't store much carbon in the soils as spruce. I mean, we found in Alaska that black spruce store about 7 times more carbon in their soils, just in the upper part of their soils, than aspen or birch. Mm-hmm. But that's a carbon consequence, right? That's not an albedo consequence. So you have to account for both of these things.
I just haven't thought about the albedo of birch. You know, they're white. Their bark is white.
Yes, absolutely. And their leaves are very light and fluffy. And
I never thought about that. I remember, when I think of Russia and trees, the tree I always think of is birch. I think flying into the airport in Moscow, you as you land, you see all of these birch trees with white bark.
Yeah,
it hadn't occurred to me that has potentially maybe some significant albedo effect, as having white trees.
It definitely does. And you can see in aerial images and even high resolution satellite imagery that the trees that have a pretty dark bark, even in the winter time, they'll have a thawed area of snow around the bole of the tree. So that's just from heating, Mm-hmm. So you have to consider both the energy balance and the carbon balance. Both of those things come into play.
You need a real mathematician to work out this kind of equation.
Yeah, so people are doing that. We have modelers that are doing that and trying to put it all into account, and we, feed them our carbon numbers all the time. And it depends, right? I mean, there are papers in Alaska that say that increased deciduousness should have a cooling effect.
Say it again. Increased the spread of deciduous forests should have a cooling effect.
Because of the energy, yes.
But people don't all agree on that.
Yes, there's lots of things going on.
Yeah.
It gets very complicated.
Okay, tell me about larch and aspen, because as I recall, those are two of the other species that tend to be spreading in the Arctic. Is that right?
Aspen in some places, but larch is like, it's not that common in North America, but larch is the dominant tree across high latitude forest in Siberia. There are several species. It's an incredibly interesting tree because it is a conifer, so it has needle leaves, but it's deciduous. It drops its leaves every year.
Do they have to be in cold soils, or are there any of them? I look out my window. There are trees out there. I have no idea what they are. Could any of them here in Toronto be larch trees?
I don't know in Toronto. There are larches in the U.S. I know, like in Montana and Idaho, they're called western larches. They're larch forest up there. There's some larch in Alaska, but not a lot. I mean, it's not like Siberia where that's all there is in those high latitude forests. I mean, where I work in Siberia, that's the only tree. on our sites is large.
Now, from the general consensus, if there is such a thing now, would you say that the view is that larch is your friend or your enemy if you're trying to prevent the melting of permafrost?
I think from our data that larch, yes, I think they're protecting the permafrost. I will say that. Some people will argue with me, but based on the data that I have collected, and that's what I feel confident in right now, when we have forest, there is more protection of the permafrost than when we have shrublands. I have data to support that.
Okay. Well, all right. So that's very okay. So if you're in charge of saving the world, and your beat is reducing permafrost, we're all going to agree on one thing. We've got to reduce emissions ASAP, right?
Sure.
But globally, but that's a global effort that ain't going nowhere. It's really hard. And in the short term, we're sounds like the permafrost melt might do us in before we have a chance to cut our emissions enough. So what are we going to do? We're going to do controlled burning.
Well, I think that's something we could do in non-permafrost ecosystems that could help. But
sorry, in the permafrost areas, what are we going to do?
Yeah, I don't think prescribed fire is something we do in permafrost areas. In permafrost areas, again, not to sound fatalistic, but it's very difficult because what we can do is pretty limited. It's a vast area that's so remote. I mean, when I fly from Yakutsk to Cherski, which is where we base most of our field work on, which is very close to the Arctic Ocean and just north of the Arctic Circle, there is nothing, literally, except for a couple of little villages that people have accessed by boats. Between Yakutsk and Cherski, most of those places you couldn't even land a plane in.
Because of trees.
Well, because it's mountainous and it's dissected by rivers and streams, and it would just be logistically very difficult to get to a lot of those places. And so I don't think we can actively do anything in a lot of those places. We talked the other day a little bit about this, and I know you're interested in Pleistocene Park, the Zimov's plan to rewild the Arctic as a mechanism for mitigating climate change. And that maybe has some potential. But again, the feasibility and logistics of doing it over a large area is very complicated. You might be able to do something regionally, but I think there's still a lot of debate about whether or not what they want to do will actually work.
Or whether it could be done.
Or whether it could be done, right.
The whole effort of where you're going to get all those animals, how are you going to keep them healthy, how are you going to get them in there, do they need shelter, do you need to give them extra food, do you need to have veterinarians go look after them, all kinds of concerns that I think, on the other hand, that is one of the few proposals that I've come across that even offers any hope. I mean, you've just dashed any prospect of being able to prevent the expansion of the forest or the forest fires there.
Yeah, I think the idea of planting in the trees in the Arctic holds a lot of, the growing conditions there are so poor that the growth rate of trees is very, very slow to begin with. And so it's not like trees in the tropics. Probably if we're going to focus on reforestation and planting trees, we should do it someplace where the productivity is very high and where we've already caused a lot of damage through deforestation, like in the tropics. I think it makes much more sense to focus on those regions than to focus on the Arctic, which is logistically impossible to work in a lot of the times, extremely cold and very, very low productivity of trees to begin with.
Mm-hmm.
And when I say productivity, I mean the ability of those trees to photosynthesize and pull carbon out of the atmosphere and put it into their own tissues. It happens very, very slowly.
Mm-hmm.
And fighting fires in the Arctic, you can do in some areas where there are cities and villages, but most of the Arctic is so remote that you cannot do that. It's would be very, very difficult to do.
Mm-hmm.
So
Kind of a grim analysis. That, in fact, I want to do, as you know, I want to do a talk show specifically about the Pleistocene Park idea and the potential feasibility of, expanding on the idea and trying to make it into a major operation.
yeah, I think Nikita just published a paper recently. Did you see it about the feasibility of Pleistocene Park?
I don't believe I've seen a recent one. No, I better find that and look at it before I try to do an interview. I would love to interview him in particular. I don't know whether
He might talk to you. He's exceptionally bright and very eager to discuss Pleistocene Park. I think in his paper he talks about a lot of the issues and how difficult it would be to do across a large scale. But
is his conclusion optimistic or pessimistic?
I think it's balanced. You know.
Yeah.
You know, I mean, there is some merit in what they're proposing. I mean, it makes sense in a lot of ways. It's tricky. Like, I don't know that converting forest into grasslands is the right solution. I think maybe where you already have grasslands and where you might be able to get herbivores in there to maintain them as grasslands, that makes a lot of sense.
Mm-hmm. What about the areas that are covered with sedge and moss and lichens and just not very much grass? As I understand, that's a large area. Could the use of large herds of animals turn that into grassland?
It could potentially, and you know, those systems are very interesting because they have a lot of they call them. It's a Russian word. They call them a loss. These are kind of sunken lakes where the permafrost has thawed and it's caused a depression, but a lot of times the water will drain out from those over time, and then those will grow back as grasslands. And in central Siberia, a lot of the native people use those as grazing grounds for their wildlife.
Uh-huh.
And they could really capitalize on these losses because they're happening in a lot of places. And so the losses are usually very highly productive. They have really rich soils, lots of nutrients, grasses come in. And as long as you had herbivores around, they would maintain them as grasses, as long as your density wasn't too high. And so I think they could capitalize on that. So I think if you have a system that's already a grassland or a shrubland, and you can maintain it as that through herbivory or through rewilding, that makes a lot of sense. I'm not completely convinced that converting forest to grasslands is a good approach, because the forest, at least the large forest that I work in, they shade those soils and they develop a really thick organic layer, and that keeps the soils pretty cold. So I don't know that I would go from forests to grasslands, but I certainly think there's some merit into keeping grasslands through herbivory.
Yes, one of the papers I read did puzzle me, because that was the only place I'd seen any reference to the notion that you have these sudden sort of pits, or
Yes.
I don't know how big they are, maybe the size of a football field or something, where the water
Sometimes bigger than that. Yeah.
Bigger, and that they subside, and then that the grass grows there. But I would have thought that would also be a place where you might have more methane production.
You could if it stays moist, but what happens gradually over time is that the water drains out of it. And so it's like you'll have a slump, it collects a lot of water, and it'll be a lake for a little while. And when it's a lake, then you could potentially have a lot of methane emissions. But over time, as the sediment starts to accumulate and the plants start to come back in, then the grasses start to take over, and then it becomes this sort of lush, beautiful field of grasses, which like I said, near Yakutsk, the native people are using that for their livestock and to feed their horses and their cattle, and it's very productive. And so grasses are extremely productive. I think, and Nikita actually at Pleistocene Park a couple of years ago intentionally drained there a loss. He created a ditch essentially from the lake into the river to drain the water out of it, to convert that into a productive grassland that could feed the animals that he was bringing into Pleistocene Park. And to me, that makes a lot of sense.
Mm-hmm. Now, a couple of years ago, we had a conference here at the faculty club, and they brought some Russians. And one fellow showed a bunch of pictures of something that I've never seen referred to much elsewhere. And that was, he said that there are a number of places in Russia, presumably Siberia, where you see a perfectly circular lake that they don't understand what it's all about. And they think that these are places where there was an actual explosion of underground methane that blew it up and made a perfectly circular place that then, I don't know where the water came from, but at any rate, filled up with water. And then they discovered this perfect lake. That's different because it's not just a gradual subsidence of land from the melting of the permafrost, but an actual explosion.
Yeah.
About those?
I don't know that. I haven't heard of those. It doesn't surprise me, but I'm not aware of those.
Mm-hmm. Okay.
Well, Nikita always does. He has this video of him standing on top of the ice of a loss in the wintertime, and he drills a hole in it, and then he holds a match up to it, and this huge flame comes out. Mm-hmm. And it's because there's so much methane that's being generated in that, this is while it's still a lake, underneath that ice in the wintertime, that it all just kind of comes out. And so there's certainly methane being produced in these losses when they're still when there's still water on top of them.
Yes, and in that connection, I think I saw somebody arguing that if you're going to have methane emissions from any place, you see people going out in the middle of the lake and drilling a hole, and then there's a big thing, that actually it would be a very good thing to go around burning it, because the burning the methane is less deleterious than just letting it escape into the atmosphere. I don't know the chemistry of burning methane, but if you, of course, the ideal thing would be if you could capture it, put a balloon over it and take it home with you and put it someplace. That would be very good, because then you could use it for fuel. But just burning it might be better than letting it escape. What are the variables that determine the speed at which this methane is being emitted? Besides trees, what else? I mean, I think most people who are foresters and anybody else would say that the majority of the methane being produced by the melting permafrost is simply caused by overall global warming and not by any local phenomena. But trees are local, and big animals are local, grassland production is local. So question is, what, in addition to trying to hurry up our reduction of carbon emissions globally, what can we do on a local basis to reduce the speed at which the permafrost is thawing?
I get overwhelmed sometimes when I think about massive tree planting efforts or, rewilding the entire Arctic. To me, that seems overwhelming. And so I like to think about things that I can do personally. I don't know, and those are the things that I try to influence. And those are things around my own personal lifestyle choices.
I think if I can make any difference at all, it is in trying to get other people thinking about issues that, in fact, we tend to prefer not to think about because it is so discouraging.
Yeah, absolutely.
It is simply, as you say, overwhelming. The challenge is stupendous. And yet I'm with Greta Thunberg saying, yeah, our house is on fire. You got to do something. And even if you don't know what you're doing, and that's the reality. We
Right.
don't know enough now. And I think the most important thing that we can do is encourage a stupendous rush of research just to try to find out as much as we can, as fast as we can,
Right.
and not, frankly, at the speed at which academic research or even governmental organizations like Natural Resources Canada or Parks Canada or these outfits that manage our affairs, the rate at which these discoveries are being made and publicized, I'd have to say is not sufficient. And if I'm out there prodding people and making your life miserable, for example, by saying, hurry up, it's out of a sense that, yes, our house is on fire, and by God, we better hurry it up.
Yeah, I certainly agree with the notion that things could get bad. I mean, we don't know what will happen once we hit some tipping points, and it looks like those may be happening faster than we anticipated.
Mm-hmm.
And so, yes, we all need to be aware, and we need to be contemplating this and not living in denial, which is what I think a lot of people do. But I also don't want everyone to feel so overwhelmed that they don't want to do anything, right? Because they're just feeling like this is so out of my hands.
And hats off to people who are doing their best to change their lifestyle. A current one right now that's on my mind is, these big cruisers, cruise liners. Someone told me a day or so ago that they emit as much as like all the cars put together.
Oh, wow. Yeah.
Tremendous amount of, and people do not need to go on these damn cruises. I've
Right.
taken a cruise myself once, and it's so boring. I don't know why you want to do it, but at any rate,
Doesn't sound very exciting to me either.
but at any rate, I think my current pitch would be to really make a difference. We ought to cut out these cruisers, these liners, and we ought to stop planting for lawns and turn our lawns into forests,
Yep.
urban forests, or at least vegetable gardens.
Yep. Absolutely.
Lawns are apparently really bad. They
Yes. Use
do.
a lot of water and fertilizer and don't sequester a ton of carbon. So
That's right. Yeah. So anyway, there are things that matter more than others, and I think we need to identify what really has a lot of mileage in it. What
yes.
changes might make a big difference. Thank you so much. We've used up our time, a little bit over time, and it's been a real fun activity.
Yeah, I've enjoyed talking with you. It's been a pleasure. I appreciate it.
I'm sure we'll be back in touch. Good
Okay.
wishes for your work, and thank you for what you're doing. Fabulous.
Yeah, thank you.
Okay.
Take care. Bye-bye.
This conversation is one of the weekly series Talk About Saving the World, produced by Peace Magazine and Project Save the World. Please visit our website at tosavetheworld.ca, where you can sign the Platform for Survival, a list of 25 public policy proposals that, if enacted, would greatly reduce the risk of 6 global threats to humankind. Come back next week for another discussion of a serious global issue.